Okay. Hello, everyone. Good evening. Welcome back to our English class. I hope everyone is all settled down and, of course, ready for today's or this evening's session. Another day, another session to learn something new. But before that, let me just check. Okay. I was just checking if the presentation is good, if the audio is good, so that I can move forward at ease. But anyway, all good. Everything is good. Let's continue. Good evening once again, everyone, and welcome back to our English class. This evening, we are going to continue with what we've started yesterday, the topic on oil and gas vocabulary. Now, let's do a review of what we've discussed last night, no, last meeting. So we define oil and gas. Of course, we started by defining what oil and gas is. As I've mentioned yesterday, oil and gas are natural resources that take millions of years to form. So they began as tiny organisms in prehistoric oceans that were eventually buried under layers of sediment. And over time, high temperatures and intense pressure transformed these remains into crude oil and natural gas. When we say crude oil, that is the oil that is unprocessed raw oil. So that is crude oil. And of course, because these resources are buried miles underground, discovering them requires sophisticated technology. So, geologists, engineers explore the Earth's crust just to find the hidden reservoirs. And these deposits are often found in some of the world's most remote environments, which include deep under the ocean floor or beneath the massive ice caps. And we've also established what are the three main sectors of getting or the whole process, the complex process of getting oil and gas. So we have the upstream, which is more on exploration and production. We also have midstream, which is on transportation. And then, of course, downstream, which is on refining and marketing. Uh, okay, okay, better. So those are different, those are the three main sectors. When we talk about getting oil and gas, we also talk about measuring, moving resources. So yeah, and of course, we understand the importance of talking about this because this is beyond just fuel. While we often think of oil and gas as just fuel for cars or heating for buildings, their impact is much broader. The products refined from oil are used to create essential materials like plastics, fertilizers for agriculture, and even components for life saving medical equipment. So, this industry is a vital service that powers our technology. It also supports global trade. No, that's globalization. It also enables the high standard of living that many enjoy today. Now, there are 25 essential terms that every professional should know. No, 25 essential terms that you should know when we're talking about oil and gas. So, 25 vocabulary, 25 words, not really words, but terms because it's more than one, no, usually. So, yesterday we've already talked about these words. We have barrel of oil. When we talk about barrel of oil, this is a standard unit of measurement for crude oil, which is equal to, I'm so sorry for that, which is equal to 42 US gallons or 159 liters. So, that is the standard no measurement. But when we talk about barrel of oil, it is not just a container. It is a precise mathematical definition used to track the excuse me, used to track the lifeblood of modern industry. So that is a barrel of oil. Okay. We also have what we call blue barrel. Now, Why blue barrel? That is the abbreviation of that is BBL, right? Well, because um the industry uses such a specific number like 42 because this specific measurement it originates back to the 1860s Pennsylvania oil fields where they use color blue barrel, and it just been used even today. No, they keep it. So that's why it's used as that one. Now, we've also understand that there is a process from the well itself, from getting the oil from the well to the barrel. So the journey of a barrel begins deep in the earth. Before a single gallon can be measured, the industry must engage in upstream activities. They do exploration. No, they try to use any kind of technology, seismic technology, to find oil trapped in rock layers. And then after that, they also do drilling. No, they once found that once found like they found that this specific part is or has oil. They do drilling to reach the reservoir, and then extraction, of course. So the crude oil is pumped to the surface, and at this point, it is finally measured and officially becomes part of the millions of barrels per day count. Okay. Next to that is again that is Next to that is blowout preventer. Now, when we talk about blowout preventer, this is a large specialized valve installed at the wellhead to seal, control, and monitor oil and gas wells to prevent uncontrolled release blowout. So basically, a blowout preventer or BOP, we establish it as a critical safety device, right? So it is a really specialized valve installed at the wellhead. So it you can think of it as the ultimate safety switch for an energy well. Its primary job is, as mentioned here, to seal, to control, to monitor what? To monitor oil and gas wells to prevent an uncontrolled release of pressure. So this uncontrolled release of pressure, this is also known as a blowout. So that we're trying to avoid that one. Okay. Again, the BOP or blowout preventer, it is a critical safety device. So it is considered the last line of defense against environmental disasters or any kind of rig accidents. Okay. And then aside from that, we also have talked about casing head gas. Again, casing head gas. Now, when we talk about casing head gas, that is the natural gas produced from an oil well, dissolved in crude oil underground and released at the surface as pressure decreases. Basically, casing head gas is a type of natural gas that is produced specifically from an oil well. It exists as a gas that is dissolved in crude oil while it is deep underground under high pressure. So basically, um, an oil is brought to the surface, and as it is brought to the surface, the pressure decreases, right? Because the deeper you go, you explore Earth, the higher the pressure it is. So much like opening a bottle of soda, the gas bubbles out and is released at the surface. So that is a natural gas. That is the casing head gas. So the gas that is collected there, that is the casing head, which is the very top of the well casing. Okay. You might also hear this gas referred to as associated gas because it is associated with oil or wet gas. No? So that is casing head gas. Next, how many terms we've had? Three terms. Next, catalytic cracking. Now, catalytic cracking is a refining process that uses heat and catalysts to break down large, heavy hydrocarbon molecules into lighter, more valuable products. I've mentioned earlier when we talk about catalytic cracking, it is a high tech refining process which is used to break down large, heavy hydrocarbon molecules into smaller, lighter, and more valuable products. So crude oil, which is measured by or in a barrel of oil, contains many different types of molecules. Some are light and easy to use, while others are very heavy and thick, like tar. So to make enough fuel for everyone, refineries use catalytic cracking to crack those heavy molecules apart. That's how technology progress over time. So the main goal of catalytic cracking is to create the fuels that power our world. So before the process was invented, refineries could only get a small amount of gasoline from a barrel of oil. So basically, if you think about it, the development of catalytic cracking changed the course of history because it moved refining away from simple boiling and into the world of advanced molecular science. Okay, that's catalytic cracking. Next, we have directional drilling. So, this is the practice of drilling non vertical wells, intentionally deviating the well bore along a planned path to reach targets not directly below the surface location. So directional drilling is basically, um, in comparison or unlike traditional methods that only go straight down, this technique involves intentionally deviating or going away from the wellbore along a planned path to reach targets that are not directly below the surface location. So there is flexible angles, no? It has extended reach, and of course, we can say that there are precise targets. Okay. And then next one we have drill bit. Now drill bit is the cutting tool attached to the bottom of the drill that breaks the rack to create the well bore. That is an instrument. So a drill bit is the specialized cutting tool attached to the bottom of the drill string. So its primary job is, as mentioned here, to break rack and create the well bore. So that is its primary job, because when we talk about well bore, it is the actual hole that allows for the extraction resources, and it's very important to also prioritize that one. And because we know that different parts of the earth have different types of rock, of course, the the engineers must choose the right bit for the job, because there are multiple types of drill bits according to what type of rock we have at this particular location. Is it soft clay or solid granite? From that range. So there are three main types. We have the roller cone bits, the fixed cutter PVC bits, and also the diamond bits. So this is used for the hardest formation, diamond bits. So how does the drill bit work? It is um, we navigate first in directional drilling, and then while the bit creates the path, the BOP remains ready at the wellhead to manage the intense pressure that the bit might encounter deep underground. And of course, once the bit was successfully reached the reservoir, the industry can begin capturing the barrel of oil and the casing had gas that bubbles out of it. Okay. Next, we have drilling fluids. Drilling fluids mentioned here is specially formulated fluids, also called drilling mud, circulated through the drill string and wellbore during drilling operations. So that is a drilling fluid. So they are far more complex than simple water. They are precisely engineered chemical mixtures, really designed to perform multiple life-saving and efficiency-boosting tasks deep underground. So that is a drilling fluid. Okay, because when we think about it, without drilling fluids, it would be nearly impossible to reach a barrel of oil because the mud performs several critical roles at once. They can be used to cool the bit because it cannot be avoided that drilling through thousands of feet of solid rock creates immense friction, which causes for the bit to be hot. So the fluid serves to cool the bit, and of course, aside from cooling, it's also used for lubrication, so as to prevent the equipment from melting or snapping. They also use for carrying cuttings, to maintaining wellbore pressure, to wellbore stability, and such things. Okay, So the drilling fluid is the first line of defense in well control. Works alongside the BOP to keep the rig safe. Okay. All right. So drill fluids is really important, just like any other that were mentioned earlier, because by using specially formulated fluids, the industry can drill deeper, can stay down longer, and safely bring the energy the world needs to the surface. That is drilling fluids. We move on to the engine oil. Have we discussed this one? Let me just check. So we started with barrel of oil. That is one, two, three, four, five, and six, seven. Okay, so we ended yesterday with drilling fluids. There are seven words that we've discussed yesterday. So let's start with new one today. We are going to continue with more terms that pertains to oil and gas, starting with engine oil. So engine oil is a petroleum derived or synthetic lubricant used in internal combustion engines to reduce friction, cool components, and protect against wear. Okay, that is engine oil. It is a specialized lubricant. Okay, so whether it is a car, a ship, or the massive generators at a train station, engine oil performs several essential roles to keep equipment healthy. First is they can reduce friction. So it coats moving metal parts to prevent them from rubbing together and for wearing down. They have also cooling components. As an engine runs, it creates intense heat. So to avoid that one, to ease that one, the oil helps absorb and carry the heat away. And then, of course, wear protection. It provides a protective barrier that extends the life of the engine. And advanced additives. Modern engine oils contain detergents to keep the engine clean and antioxidants to prevent the oil from breaking down. So when you look at a container of engine oil, you will see a grade such as 5W30, 10W40. Now this is the SAE viscosity grade, which tells us how thick or thin the oil is under different conditions. The meaning of W is a common misconception that it stands for weight, but it actually stands for winter. Cold starts, this number indicates the oil's viscosity at cold temperatures. And of course, proper viscosity ensures that when you start your vehicle to go to travel places like the airport, the oil is thin enough to flow immediately to all parts of the engine. Now, we also have what we call synthetic versus conventional oil. When we talk about synthetic and conventional oil, the industry has evolved to create different types of oils to meet the demands of high performance machinery. When we say conventional oil, this is refined directly from the raw crude found in a barrel of oil. That is conventional. Synthetic oil, on the other hand, these are chemically engineered lubricants because their molecules are more uniform, and synthetic oils, I'm so sorry. Synthetic oils last 2 to 3 times longer than conventional oils. So, so that's a good thing, right? But when you look at the value, um, of course, more expensive to produce synthetic oils are offer superior protection in extreme busy environments. So it's just that it has more value. It is much more expensive considering the convenience it's giving to us. So yeah, that's understandable. Then the importance of Indian oil cannot be overstated. It is a critical, vital service for the global economy. Okay, so that is engine oil. Next to that, we have a fault trap. So a fault trap is a geological formation where a fault or fracture displaces rock layers, creating a seal that traps oil and gases in reservoirs. Okay, so one of the most common structural traps, impermeable rock on one side, Akasia. So those are things that was mentioned here in the PowerPoint presentation. So fault trap as mentioned, is a geological formation where a fault or a fracture or a crack in the Earth's crust displaces rock layers. Now, this movement creates a physical barrier or a seal that traps oil and gas in reservoirs. So, how does this particular thing form? Over a million of years, the Earth's tectonic plates move. We know that, right? Which, of course, they move. When they move, they cause rock layers to break and shift. And when a layer of porous rock, which can hold oil, is pushed up against a layer of impermeable rock, which oil cannot pass through, a trap is formed. Okay? So the seal, the impermeable rock on one side of the fault acts as a wall, stopping the oil and gas from moving farther down through the earth. So that is really just a trap, basically. No, it seals over the oil if it meets the impermeable rock. So the fault trap is classified as one of the most common types of structural traps in petroleum geology. Okay, and because these traps are hidden miles beneath the surface, engineers and geologists must use advanced technology to explore and find them. They have seismic surveys, so geologists use sound waves to map the different layers of rock, and by looking at how these waves bounce be back, bounce back, they can identify the signature break of a fault line. Okay, sorry. We also have well logs. Um, because while drilling, tools measure the properties of the rock to confirm if an impermeable seal is present next to a reservoir. So that is well logs. And of course, global locations. Fault traps are found extensively in major energy producing regions such as the Gulf of Mexico and Middle East. So fault traps are really responsible for some of the largest discoveries in the history of the energy industry. Say, for example, the Prudhoe Bay in Alaska. It is the largest oil field in North America. Much of the energy found there is trapped partly by complex fault structures. They also have energy reservoirs. These traps can hold millions of units of crude oil, which we measure as a barrel of oil. Okay, so that is a fault trap. But of course, when with that in mind, when a company decides to drill into a fault trap, they must be extremely careful because these traps hold back massive amounts of pressure. Safety is the top priority here. So, as the drill bit enters the trap, the sudden release of pressure from the oil and gas must be controlled. This is where the blowout preventer becomes vital, or the BOP, to act as a critical safety device. Okay. Next, we have we talked about engine oil, fault trap, and now we have the gas station. A gas station is a retail facility where motor vehicles are refueled with gasoline, diesel, or alternative fuels, also called a filling station, petrol station, or service station. So, a gas station, it is a retail facility where vehicles are refueled with various types of energy, which are the gas and diesel or alternative fuels. That is highlighted in there. So, um, uh, for most people, the gas station is the only part of the oil and gas industry they interact with regularly. No, that is basically the face of energy. In the United States alone, there are over 150,000 gas stations serving millions of drivers. So it is really a national presence there. And an average station pumps about 4,000 gallons per day, making it a bustling hub of community activity. So this is really a busy center. Okay. So the way we refuel our vehicles has changed significantly over the last century. Before the modern service station existed, the gasoline was sold in cars at general stores and pharmacies. Okay, so the first station was, of course, the first purpose-built gas station opened in Pittsburgh, Pennsylvania. So today, stations are becoming energy hubs. Many modern stations now offer EV charging alongside traditional fuel to support the next generation of transportation. Okay, so that is a gas station. So it's already 6:25 p.m. Let's take a break so that it's not overwhelming for you. We will be back in 5 minutes at 6:30 p.m. Goodbye, and of course, drink your water, have a biological break, and everything else that you need to do. We will be back by 6:30 p.m. Okay, I'm back. I hope everybody is settled in and ready to continue our discussion this evening. Again, we've already talked about um, engine oil, fuel trap, and gas station. We move on to what we call gusher. Now, gusher, it is an uncontrolled release of crude oil or natural gas from a well after pressure is encountered, which causes oil to spray violently into the air, which is, of course, very harmful. So, um, it often reach hundreds of feet above the drilling rig. Gushers is also known as a blowout or a wild well. So, this is what the blowout preventer is trying to avoid. As the drill bit um as the drill bit process or pierces a reservoir, this is the cause, everyone. As the drill bit pierces a reservoir such as the fault trap, the pressure inside the trap is so much higher than the pressure at the surface, so the oil is forced upward through the wellbore at high speeds. So in the early days of the industry, gushers were common technology managed to because um technology were used to manage underground pressure, and that was limited. So the most famous gusher in history is the Spindletop Gusher of 1901, which is located in Beaumont, Texas. This single event fundamentally changed the global energy landscape. No? The Spindletop Gusher shot oil 150 feet into the air and continued to flow for 9 days before it could finally be brought under control. And at its peak, this one well produced a staggering 100,000 barrels per day. So the massive find launched the Texas oil boom and proved that oil could be found in vast quantities, which led to modernization of transportation and expansion of the gas station infrastructure. Well, while gushers make for iconic historical photographs, they are incredibly, let's say, dangerous and wasteful. In the modern industry, a gusher is considered as a major failure of safety protocols, which of course it is. That is why we have blowout preventers or BOPs. These massive specialized valves were developed specifically to prevent gushers. A BOP can seal a well in under 30 seconds if sensors detect a sudden surge in pressure. We also have the drilling fluids, no? Primary well control. It is managed by drilling fluids or mud. By carefully adjusting the weight of the mud, engineers can create enough downward pressure to keep oil and casing head gas from rushing to the surface. And because of advancements like directional drilling and real-time monitoring, gushes are now extremely rare. So it is now regulated, no? It is not like it is there is no possibility that there would be no a zero reports on it, but it's very rare because technology is very advanced in the present. So when a gusher is prevented or a well is successfully tamed, the oil can be safely collected and measured. Instead of spraying to the sky, it is diverted into tanks and pipelines. Once captured, the oil is measured by the barrel of oil, which is again 42 US gallon or 159 liters. And then we do refining. The crude is then sent to a refinery where processes like catalytic cracking will turn it into useful products like gasoline or engine oil. So this energy eventually powers the vehicles that take us to a restaurant, that take us to a park or a museum, grocery store. So that is a gusher. So far we've talked about engine oil, full trap, gas station, and gusher. We move on to injection well. A well used to inject fluids such as water, gas, or chemicals into an underground formation for enhanced oil recovery or waste disposal. Unlike a traditional production well that brings a barrel of oil to the surface, an injection well works in reverse. Okay, pushing substances down into the earth. So these wells are used for enhanced oil recovery or EOR or for the safe disposal of waste fluids. So there is really a strict regulation imposed on it because they involve pumping substances underground. So they are strictly regulated by the Environmental Protection Agency or EPA, which is through the Underground Injection Control Program. So EOR, Enhanced Oil Recovery, Finding a full trap is the only first step in harvesting energy. Often, nature needs a little help to push the oil out of the rock and into the production well. So, we try to maintain pressure as much as possible. Water injection is used to maintain that reservoir pressure. By pumping water into the formation, engineers push the oil toward the production wells. And of course, there is really a massive increase because using EOR techniques can allow companies to recover 30 to 60% more oil from a single field than they could with traditional drilling alone. And of course, gas injection. Sometimes engineers inject gases like casing head gas or carbon dioxide to help the oil flow more easily through the rock. So, modern injection wells are playing a vital role in fighting climate change through carbon capture and storage. There is really dual benefit because CO2 injection wells help extract more oil and store greenhouse gases permanently underground. So, there is a dual benefit of it. And there is what we call carbon capture. This makes injection wells a key part of the global strategies to reduce carbon emissions while still meeting the world's energy needs. Okay, that is injection well. Next to that is liquefied natural gas. Natural gas cooled to negative 162 degrees Celsius or negative 260 degrees Fahrenheit. Converting it to a liquid state, it occupies 1 over 600th of its gaseous volume for efficient transport and storage. So there is a liquefied natural gas. This is extreme cooling process that changes the gas into a liquid state. So we try to shrink the volume. When natural gas becomes a liquid, it occupies only 1 over 600th of its original gaseous volume. And this massive reduction in size is what makes it possible to store and transport large amounts of energy efficiently. So in its liquid form, LNG is non-corrosive and non-toxic, though it must be kept at these essential freezing temperatures to stay liquid. And because natural gas is usually a gas, of course, it is typically moved through pipelines. However, you cannot like build a pipeline across an entire ocean. This is where LNG technology becomes a vital service for global energy. No, LNG or liquefied natural gas enables transport across oceans via special tankers, and these ships are essentially giant floating thermoses designed to keep the liquid at negative 162 degrees Celsius. And of course, a single LNG carrier ship holds enough energy to power a city of 70,000 people for an entire year. And these ships are among the most expensive vessels ever built because of the advanced technology required to handle cryogenic liquids. And liquefied natural gas has its own life cycle from well to home. So the journey of LNG is a perfect example of the global energy chain in action. First, we have the extraction. Natural gas is produced from a well, often alongside oil as casing head gas. So it might be found in geological structures like a fault trap. So we do extraction. And then liquefaction. So the gas is sent to a plant where it is cleaned, it is cooled until it turns a liquid. So the liquid is loaded into a tanker and shipped to a different country that's on shipping. And once it reaches its destination, the LNG is regasified at import terminals. This means it is warmed back up until it turns back into a gas. So, without all the process that it takes, last thing is, of course, distribution. The gas is then sent through local pipelines to heat homes or power a restaurant where people enjoy dinner together. Okay? That is liquefied natural gas. How many are we how many were we able to talk about? First is engine oil, fault traps, gas station, gasher injection wall, and liquefied natural gas. And then this is our sixth term, natural gas. It is a naturally occurring hydrocarbon gas mixture consisting primarily of methane, CH4, used as a major energy source for heating, electricity, and industrial processes. Natural gas is basically one of the most significant energy resources energy sources on the planet, serving as a primary driver for heating, for electricity generation, for complex industrial processes. So, as a naturally occurring hydrocarbon gas mixture, it is a cornerstone of the global transition toward cleaner and clearer energy production. Natural gas is primarily composed of methane, typically making about 70 to 90% of the mixture. So, in addition to methane, it contains other wet gas components like ethane, propane, and butane. So, this resource is found deep within the underground rock formations and shale deposits. It is often trapped by geological structures like a fault trap, where impermeable rock acts as a seal. And when natural gas is found dissolved in crude oil within a well, it is specially referred to as casing head gas. So, as the world seeks more sustainable energy options, and natural gas has taken a leading role due to its efficiency and lower carbon footprint compared to other fossil fuels. Okay, and that is natural gas. We do extraction and then fractionation, heavier hydrocarbons. We're talking about that. Refining, integration, cracking, and of course, end use. Catalytic cracking, and of course, end use. Okay. Next to this is oil field. A group, I'm sorry, a geographic area containing one or more oil producing wells tapping into a proven underground petroleum reserve. So, from the initial discovery of resources in an oil field to the final products used in our daily lives, every step is a feat of modern science. So, the journey begins in the upstream sector where geologists look for natural containers deep underground that hold hydrocarbons. So, oil and gas are often found in a fault trap. We know that. A formation where a fracture of the Earth's crust displaces rock layers, creating an impermeable seal that prevents resources from escaping. So, a geographic area containing one or more wells tapping into these reservoirs is known as the oil field. And the largest in the world, the Gower field in Saudi Arabia, has produced over 75 billion barrels since 1951. That's how massive it is. So, to reach these targets, engineers use directional drilling to steer well bores along planned paths. This allows them to reach reservoirs a mile away from the surface location, it today, even if it's drilled horizontally. Okay, so that is oil field. Next, we have oil rig. Now, oil rig is the complete set of equipment and structure used to drill a well, including derrick engine, mud system, and all associated journey or monarchy. So, an oil rig is essential physical infrastructure used to drill a well and extract energy resources from deep within the Earth's crust. For far from being just a single machine, an oil rig is complete set of equipment. Um, Structures, we also capture that one. Machinery, designed to operate in some of the most challenging environments on the spot, on the spot, and you're trying to steal it. Of course not. Okay, we do not do that. So the term oil rig refers to the entire system used for drilling, which includes the iconic derrick, powerful engines, a complex mud system, so all associated mechanical components. So yeah, to successfully reach a full trap or natural gas reservoir, an oil rig must manage survival high-tech systems simultaneously. Okay, okay. Where are we? We already had engine oil, full trap, gas station, gas or injection mold, liquid, natural gas, oil field, and oil rig. Okay. So offshore rigs represent some of the greatest engineering feats in history, which is designed to withstand hurricane force winds and freezing temperatures. So the world's largest offshore rig, located in Russia, where it weighs over 200 million tons, right? So the world's largest offshore rig, located in Russia, says weight over 200,000 tons. to put its size in its perspective, it's heavier. Yeah. So yeah, that is the energy connection. The work performed in an oil rig is the first step in a chain that powers our modern world. So we do collection. The process is collection. Once a rig is successful taps into an oil field, the raw crude is measured and eventually sent for refining. Refining is a crude. The crude is transformed through processes like catalytic cracking into fuels like gasoline or diesel. Okay, so we do collection. The raw crude is measured and eventually sent for refining. Refining is the next process. The crude is transformed through processes like catalytic cracking into fuels like gasoline or diesel. And then of course these products produce eventually reach your goal, local gas station or provide the family. Okay. Now oil the keeps your car running, of course. That is what? An oil rig. So after again the whole complex process, we do collection, refining, distribution, and of course natural gas. Rigs also capture casing head gas, which can be processed into energy for homes or cooled into liquefied natural gas for global transport or LNS. Right? Okay. Now, for any student interested in engineering geology, the oil rig is a lively example of how humans solve complex problems to access natural resources safely. So the rig is the home base for all drilling operations. That is the infrastructure. Without the precision of the rig and its crew, we could not safely access the um, energy that is, of course, included. Okay. So what is the vital role of this particular topic? That without the precision of the rig and its crew, we could not safely access the energy stored in rock formation deep underground. Okay. We move on to oil rig. Now, when we're talking about oil rig, that is what? So, um, where is it? Okay. So the raw crude and natural gas extracted from well undergo really extensive processing before reaching the consumer, the customer. So we always refine it, no? Processes like catalytic cracking break down the heavy molecules from the well into gasoline and dense. So this energy eventually powers our transportation from the fuel at the gas station and the engine oil um, that protects our vehicles. So global shipping or knowing LNG, natural gas from these wells can be cooled to negative 162 degrees Celsius to create liquefied natural gas, allowing it to be shaped accordingly. Okay, okay, that is what that is that is resource coverage. We started with different words, right? We started with this one. Okay, that's one, two, three, four, five, six, seven. Six words yesterday meeting. Today we talked about one, two, three, four, five, six, seven. Okay, well, that's already good enough. And then, um, um, when we're talking about what you call that? When we're talking about natural gas, what do we do? Well, we try to be in depth about it because it's boring in depth. A typical well has an average depth of 5,000 to 15,000 test feet. So for perspective wells, the deepest well, the live must ensure that the well is, you know, that big. As the boring reaches its target, such as a noid underground fall trap, the extraction process begins. Okay, so wells produce resources using natural pressure, mechanical humps, or the, mechanical pumps or artificial lift techniques. So modern wells are not always right. You might okay. So wells produce resources using natural pressure. That's the method of extraction. And then we have so it's really just how to call that? It's just really focusing on drilling on oil, which is a massive engineering undertaking that requires precision and specialized tools to handle intense pressure and heat. So it's once the boring reaches its target, such as underground fault trap, the extraction process begins. Methods of production wells produce resources using natural pressure, mechanical pumps, or artificial lift. And then of course they try to sleep it down. Of course. Well, that is directional drilling. Again, that is to intentionally deviate the wellbore, allowing them to reach reservoirs miles away from the surface location or even drill horizontally. Okay? And then throughout the drilling process, mud or drifting or drilling fluids are circulated to cool the drill bit, carry rock cuttings to the surface, and maintain wellbore presence, preventing scores. Okay? So, yeah, that is it. Now, the life cycle of an oil field. Again, we talked about the last one, which is oil field and then oil rig. The life cycle of an oil field. So, a single well is usually part of a larger oil field, which is a geographic area containing multiple wells tapping into a proven petroleum reservoir. Okay, so yeah, that is basically the life cycle of an oil field. Oil fields can span hundreds of square miles and include complex networks of pipelines and processing facilities. And that is why the enhanced recovery, when a well's production begins to slow down, energies may use injection wells to pump over over the problem into the formation. So these engineers may use injection wells, and of course, it can increase the total amount of oil recovered by 30 to 60%. So, from raw, crude, and natural gas extracted from the oil undergo extensive processing before reaching the consumer. Because again, we do refining, a lot of refining first, and then it's everyday use, and of course, global shipping. Okay, so how those are the different words for this evening. Let's try to go back. First, we had okay, that's one drill bit. No, not one. Engine oil. The next to that is gas station, then gasher, injection wall, liquefied natural gas, and natural gas. One, two, one, two, three. One, two, three, four, five, six, seven. Okay, that is it. No, for what is this one? Okay. Yeah, that one. But yeah, she was once in Miss Universe and just didn't won. Okay. So the rock crude oil here, always think about it. As natural gas extracted from the well undergo extensive processing before reaching the consumer. Okay. We do all those things. We do refining. We do checking it in a blood person, a physician. Then it allows to be shipped efficiently across oceans. Okay. So once refined, of course, the natural gas oil rig is still not moving on. Okay. Okay. And then this is the last one. For a moment, I cannot see its title. Or is it just me? I think it's just me. But anyway, the last topic is on oil rig. Again, the complete set of requirements and structures used to drill a well, to drill a well as a man. And then Derek engines. Just correct as it one. Okay. So we ended with oil rig. How many? One, two, three, four, five, six, seven, eight, nine. So there are nine people in there. Not to mention, she was also able to roughly talk about it. But yeah, no, we're talking about that one also. Well, we're going to end our session here in the Philippines. So we're going to focus on that one. And then after that, well, it's different from each country, so we're going to take note of that. And that is all for the session this evening. There are a few more words left, so our last session will be tomorrow, and after that, we'll do exercises. Okay. So that is all, everyone. See you more in see you more and participate more tomorrow during our discussion, please, because I am constantly checking the chat box, no, in um in case there are changes, in case and there are things that I need to know, so I'm constantly checking it. So you all just have to really give me responses, ask me questions. I would love that, and of course, s- it will be very hard to really study with a particular student, but I'm encouraging you to study. Okay. All right. That is all, everyone. Goodbye, and I hope you will have a great rest of the night. Goodbye, and thank you. See you soon. See you around.